I'm Martin Pickering, and in this box I have the new Powerbox-Systems iGyro 3 Extra. A lot of you have been asking for this one, so let's get straight into when we should use this unit and how it works. I'm not going to go into a load of detail about gyros. I've done that many times before in previous videos. So let's just remind ourselves that gyros are not autopilots. You still need to use your thumbs to fly the plane. They just make the plane track straighter, especially when windy. And we can also use them to help us out in vector jet systems. Enough chit chat though, time to get into the box. We have the usual Powerbox-Systems box packaging. We can just turn it over, cut into the stickers that keep it all shut, and with a quite Apple-esque style reveal, slowly take off the lid. Inside we have the iGyro 3 Extra, which is absolutely tiny. The 6 patch leads to connect to the receiver, a double-sided tape to secure the gyro to our model, some stickers, and the manuals, but by the time we are finished with this video, we won't need those. The iGyro itself is easily recognisable as an evolution on the previous blue iGyro 3E, where the rest of the Powerbox-Systems iGyro family originated from. For anyone looking to dip their toes into gyros for the first time, the original iGyro 3E was always my first recommendation. But why? What makes the 3E and now the 3 Extra so easy to understand? Well, 3 main points. Number 1, easy understanding of how it actually works. Just look at the box. It uses traditional PWM ports, or in plain English, 1 wire in, 1 wire out for each channel. Or if we wanted to simplify that even further, we could just say that it simply fits in between your receiver and your servos, and that's it, installed. 2, minimal basic setup. When playing with any kind of new tech in our expensive models, it's always a little bit scary. That's why the easier the setup is, the sooner it can gain our confidence. The whole basic setup is done in minutes. Just install the gyro in a given position and double check that the corrections made by the gyro work in the right direction. More on that later though. And number 3, the instant improvement that you can see and feel in flight. Once the basic setup was performed, the whole gyro is controlled by a single slider or rotary dial, meaning that in the first flight you can turn up the gyro in flight and instantly see the difference. Oh yeah, and a bonus point for you. It's small. You can fit it anywhere. So you can install it in a foamy first in order to figure out how it all works and then apply what you learned into your intended model. Even if the foamy will end up flying so good with the gyro that you may need to pick up another one for the actually intended model. But that's enough theory. This video is about the 3 Extra. So what's different? What improvements does it bring? And how do we actually use it? Well, let's start with the obvious, the case. The 3 Extra comes in the same case as the 3E did. It just changes its colour from the previous gen's blue to the current lineup's silver or grey. Moving on to actually start using it, as it has the same case, it keeps the same wiring diagram. So simply splice the gyro somewhere before your servos. Signal in goes on the left hand side and signal out goes on the right hand side. Always ensuring correct polarity, please. The negative wires are always on the outside. So if using just a simple receiver, this splice would be in between your receiver and your servos. If using a classic PWM style power box, 1 lead per channel, such as the Evolution, the Professional, etc., you would install the iGyro between your receiver and Powerbox. This alters the servo signal in the same way as normal, while also keeping all of your high power outputs from the Powerbox available to power your servos. If using a newer style SRS Powerbox, where just one lead is connected between the receiver and the Powerbox, then unfortunately this gyro isn't the one for you, and you'll need to pick up either an iGyro SRS, a Powerbox with integrated gyro, or possibly an iGyro SAT if using a Powerbox core radio. Fixing the 3 extra inside the model is even easier than it was with the 3E, and that's saying something. All we need to do is secure it anywhere in the model, in any direction or orientation, just making sure to keep it at right angles. Unlike with the 3E, which needed to use a Bluecom or USB to teach it which way it was orientated, if that was different from the predefined direction, the 3 extra learns its orientation during setup, allowing that added freedom without the need for ancillary items. On the subject of setting up via a Bluecom or a USB, with the old 3E, if installing it in a Delta or a V-Wing, a V-tail, we had to set up our radio as a standard normal wing configuration and set the Delta or V-tail in the actual gyro itself using those ancillary devices. This is now a thing of the past. The new iGyro 3 Extra doesn't need this extra step. You can now set up the corresponding wing type in your radio, normal wing, Delta, V-tail, and during setup the gyro will automatically detect what wing type has been set up and will apply the gyro corrections accordingly. Easy. Where exactly do you splice the iGyro into your wiring diagram for those unusual wing types though? After all, you can't simply follow the instructions on the case, aileron to aileron, elevator to elevator, when it's a Delta wing. Well, for those cases, the setup would be as follows. For Delta surfaces, use the inputs aileron A and elevator A with their matching outputs. An additional Delta input and output can also be routed through aileron B and elevator B. For V-tail surfaces, use the inputs elevator A and rudder with their matching outputs. For vector Delta jets, use the inputs aileron A and elevator A with their matching outputs for the Delta flying surfaces and route the vector elevator channel through elevator B and its matching output. We also need to connect an auxiliary channel to the gain input, as this will allow us to control how much gyro is applied at any time. In order to potentially access the maximum gain, also assure that the travel on this channel in your radio is set to the maximum available. So that'll be 155, I believe, in Futaba, or 200% in core radios. So, now that we know the basics, how do we actually proceed to setting it up? Well, given that all the servo settings are now entirely done in the radio, the same as if there was no gyro installed at all, the first step is to set up the radio as normal, including any wing configurations, mixes, travel adjustments, etc. Now, on to setup and mounting position. This only needs to be done once. After everything is installed and connected, it's worth pointing out that this is also how you would reset the gyro. So doing this a second time will scrap everything else that you've done. To teach the gyro the orientation in which we've installed it, we simply press and hold the gyros button down while turning the model on and release it once the red LEDs start cycling. Once released, avoid touching anything. Keep the model as still as possible while the gyro sensor carries out its self-calibration process. This will take a couple of seconds, and once completed, the aileron A LED will turn green and the elevator LED will start flashing red. At this point, lift the tail of the model quickly. As reference, the green LEDs indicate how far you've moved an axis, and the flashing red LED indicates the axis that you should be moving. So while lifting the tail of the model, you will see more green LEDs turn on the more you lift it. Once all the LEDs are lit up, you will have lifted the tail enough and the elevator axis will have been detected. All of this is confirmed by the elevator, which will have initially moved with you as you moved the fuselage, and it will now bounce back to its centre quickly. Now, at this point, don't worry about the direction in which the elevator has been moving, as we're yet to confirm which way is up or down. Now, upon completing registration of the pitch or elevator axis, as we've just done, we'll now proceed to do the same on the yaw or the rudder axis. Now, again, a single green LED will be lit up, and we must light up all the LEDs by moving the tail of the model to the right in the same way as we did with the elevator. This time the rudder LED will be flashing red, confirming that that is the axis that we must move, and the rudder itself will again move in a random direction whilst we move the tail, which will all be corrected in the next step. Now, just like before, once all the green LEDs are lit up, the rudder bounces quickly back to zero and the gyro's orientation has been detected, and the gyro reverts now back to its normal on and functioning position. It's worth noting that we only need to register 2 out of the 3 axes. The third axis, roll or aileron, is automatically calculated by the gyro, as it's the only one of the 3 axes left. Setting up the movements. In setting the servo movements, the gyro learns everything about the surfaces that it can control. This includes the servo centres, the endpoints, the wing type, everything including whether it's a delta, V-tail, etc. This setup is not only necessary prior to flying the model with the gyro for the first time, but if installed on a new model that hasn't yet been flown and trimmed, or in a model that gets retrimmed again at a later date for any reason, it's recommendable to repeat this setup once again after the retrim has been made. This will have the gyro relearn the trimmed centres of the servos and your definitive endpoints, differentials, etc. To start the setup, with the model turned on, press and hold the gyro's button for 5 seconds until the green LEDs start cycling, and then let go. The following sequence must then be followed precisely. Green LED at ailerons. Move the aileron stick to full right and press the iGyro's button. Red LED at ailerons. Move the aileron stick to full left and press the iGyro's button. Green LED at the elevators. Move the elevator stick to full up to climb and press the iGyro's button. Red LED at the elevators. Elevator stick to full down, descend and press the iGyro button. Green LED at the rudder. Move the rudder stick to full right and press the iGyro's button. And red LED at the rudder. Move the rudder stick to full left and press the iGyro's button. After completing these steps, the gyro will go back to normal operation, and if you increase the gyro gain slider, you can double check that all the surfaces are being controlled correctly by the gyro. While checking, remember that the surface in question should always correct in the same direction that you're moving it. So lifting the tail should cause the elevator to go up. Same as lifting one wing will make that same aileron go up. With that, and after double checking all the surface movements and that the gyro correction is all correcting in the right direction, we're now able to go and actually test it out. If we turn our slider in one direction, we'll have normal gain, while in the other direction we'll have heading hold. Before takeoff, check that the gyro channel slider is in its center position, so 0, off, and that you know which direction is normal or heading. Once in flight, slowly increase the gain in the normal direction and you will feel the improvement. Then go back to 0 and try it in the other direction for heading hold and see which feels right for you. If upon increasing the gain the model starts oscillating on any of its 3 axes, decrease the gain immediately. It's too much. All of the above has described the basic settings of the iGyro 3 Extra and how to control all 3 axes at the same time with exactly the same amount of gain. So all axes proportionally. And this is fine and will work in 90% of cases. If, however, you wish to get even more out of the gyro, you may want to increase or decrease one particular gain channel or axis more than the others. You can do this in one of 2 ways, either via a Bluecom or USB adapter, as we'll see in a moment, or directly from the radio without any extra accessories. The way that both options work is basically the same, by increasing or decreasing the maximum gain for individual channels. Then, as our gain slider controls how much gain is applied proportionally within those boundaries, it will proportionally increase or decrease the affected channels. So, to update a channel's maximum, enter the fine tuning menu by pressing the gyro button 5 times in rapid succession. Then move the stick that controls the axis that you wish to alter. A red LED will then indicate the center, so the current gain position for that channel. And you can move that LED to increase or decrease the gain using that same stick. Each of the LED on the gyro equates to 5% up or 5% down, depending on if it's above or below that red LED center line. Using this method, you can update up to 10% per time. To increase or decrease more, simply repeat the same procedure time and time again. Using the Bluecom or the USB, you can access all this same functionality and view the current settings, as well as having additional options to change. These include attitude assist or heading hold. It allows you to activate or deactivate it from both directions of your slider, as opposed to the default setting, which is active only in one direction. Gyro characteristics. This value can be used to speed up or slow down how quickly the gyro reacts. Depending on the model type, you may want a gentle correction, as may be the case with an old-timer scale model. Or you may want a super fast reaction on a more precise, sporty aircraft. Stick priority. This is how much the gyro is allowed to take over. Standard is 100%, so the gyro is completely off when the stick reaches either end point. If you changed it to 200%, the gyro will be off on that axis by the time your stick reaches halfway to each endpoint. This makes the model more agile, but you will also lose gyro effect a lot sooner. Lock-in feel. This feature alters how locked in the model feels. This is especially noticeable in 4-point rolls and other similar fast stop maneuvers. A wrong value here will result in the model bouncing back rather than stopping dead, or continue the roll slightly, almost like no gyro was applied. And finally, airspeed factor. This parameter is only applicable if using the iGyro 3 Extra in conjunction with the optional Powerbox GPS. If you choose to use the GPS sensor, which the larger the model's speed envelope is, the more recommendable this becomes, the iGyro will automatically reduce your chosen gain settings the faster you fly. This makes a lot of sense, as otherwise you can only add as much gain as your model can handle at high speed. But at low speed, flight surfaces are a lot less effective, and that small amount of gain will have little effect on the model's flying. So when using the GPS, the gyro gain that we set is used in its entirety at slow speeds, and then gets proportionally reduced depending on the speed at which we're flying. The airspeed factor is used to basically program quite how fast the model can fly, and therefore how quickly the gyro should reduce that gain as the model increases in speed. Fast models will have a high airspeed factor, whereas slower models will use a lower number. Oh yeah, and installation of the GPS 3 really couldn't be easier. It's a plug and play. Just connect it to the USB port on the iGyro 3 Extra and everything will talk to each other and it will start working. If using the previous version though, the GPS 2, it's still just as easy. However, you will need to program the GPS 2 for use in an iGyro via a Bluecom or a USB interface first. And that's it, the Powerbox-Systems iGyro 3 Extra. If like me though, you don't want to have to reset your gyro slider each time you change models on your radio after having found your favourite gyro settings, you can fix those values on a standard 2 or 3 position switch on the radio, thus avoiding the risk of having the slider and gain all wrong on your next takeoff. To do that, after having finished all the setup that we've just gone through, go into your radio and check out in the servo monitor exactly where your slider is positioned. Make a note of that number and replace how you control the gain channel from the slider to your chosen switch. Then just make sure that the amount of travel used coincides in the servo monitor with that number that you'd written down. Depending on where you want the gyro off position to be located, so 0% on that switch, you can also play with the curve on that channel in order to assure fixing it in the right place. But that exact process will depend on your radio, and this video is already long enough. With that said, it seems like a good place to end this video. I hope that you enjoyed it and found it helpful either in choosing or setting up your iGyro 3 Extra. If you did, leave us a like and subscribe to the channel if you aren't already. With a load more tutorials, videos and flying in the works, you're not going to want to miss out. Until then, thanks for watching and I'll see you all in the next one.